Looking at number 9, it says the exterior angle of an isosceles triangle is 106 degrees, and there's supposed to be 2 possible sets of the inside angles for the triangle. I have 2 different isosceles triangles drawn because we don't know where the exterior angle is. So let me back up a moment. We have 2 isosceles triangles. Every isosceles triangle has two sides that are identical, which means it has 2 angles that are identical. So this one would have 2 congruent angles. This one has 2 congruent angles. They both are supposed to have an exterior angle of 106, but I don't know where that angle is. Is the 106 next to one of the congruent angles? Well, that's one possibility. Is it next to the non-congruent angle? Also a possibility. That's where the 2 possible triangles come from. I'm supposed to find the angles inside, however, so I'm going to focus on one triangle at a time. 106 is next to this angle. This is not even close to the first time we've had this come up on this review. When you are right next to, when you're adjacent to each other and you're together making a straight line, those 2 angles sum to 180, which means X would be 74 degrees. But the thing is, again, this is an isosceles triangle. It's possible that, the 74 degrees that would be here is also here, which only leaves me with 1 angle left to find. But I have now 2 of my 3 angles in the triangle. I can add up the 2 angles I know in that triangle, and together all 3 of them make 180. So not only do linear pairs make 180, but angles in a triangle make 180. So I'm going to add the 2 74s and subtract it from 180 degrees. So one possible set is the triangle's inside angles were 74, 74, and 32. However, that's just one possible scenario. The other scenario is this guy, where there's still a 106, it's still next to an angle, but there's only one of those angles. So just as before, my 2 linear pairs will add up to 180, which means just as before, I will have a 74 degree angle. But unlike before, I don't have 2 74s. I have 2 of something else. But regardless, the angles inside the triangle add up to 180. So now I have an equation where I can combine my like terms, subtract from 180, and then divide by 2. So there weren't 2 74s in this triangle. This one actually had 2 53s. So the other scenario is to have 53 degrees, 53 degrees, and only 1 74. It all matters where you put that exterior angle.